There's something I always check before finalizing load calcs, and it's kind of easy to forget, but if you miss it, you'll likely oversize your systems. Diversity. Here's how it works. Diversity is a fraction applied to your internal loads on the system level, and it can be applied for people, lighting, and plug loads. But let's use people load as our example. Say I've got these zones here. If I'm sizing equipment for these zones, then I'm going to include the total number of people in each zone. This zone will have 2 people, 12 people here. I'm sizing my zones for the maximum load they're going to see. But when it comes to sizing my system load, I need to account for diversity. If I don't account for any people diversity, I'm going to be calculating for the sum of space people, which in this case is 30. But that's not realistic. Look at these space types in this example. This is an office, and if this conference room here is full, where did those people come from? They likely came from the offices surrounding that conference room. Same with this break room. If there are 7 people in the break room, then who's in the offices? So what we're trying to account for is the fact that not every space in the building is in use simultaneously. So if we apply a system diversity of 70%, then we're assuming the maximum number of people in that system is, in this case, only 21. If all these zones are served by an air handler, when I size that air handler, I'm going to calculate for 21 people, not 30. Choosing the right diversity takes a little engineering judgment mixed with some common sense, and it varies a good bit based on building types. Education will be different from healthcare, will be different from office buildings. But one pro tip I really like, if you're trying to justify some diversity, look at the parking lot. If you have a total building occupancy of 500 people, but there are only 100 parking spaces, then you probably shouldn't expect a whole lot more than 100, maybe 200 people. Airports are an obvious exception.